Hello, and welcome back to Shiksha DaCosta. Today we're going to learn about the three primary trigonometric ratios. These ratios are called sine, cosine, and tan. And you are successful if you can solve problems that come up from the real world by determining what is the measure of the sides or what is the measure of the angles of right triangles, so triangles that have a 90-degree angle. And that you can do so by using these three ratios. And today we're going to learn what they are. To start off, I'll ask you to pause the video here and answer this question. Determine the length of the hypotenuse, the side opposite the angle, and the side adjacent to the angle in both triangles. Pause for just 30 seconds here and see if you can answer that. Okay, well, hopefully you looked at this triangle. You saw, okay, here's the angle. I know that the opposite side is probably not the two sides that are touching it, but the one side that is across from it. And so that's 1 centimeter. Adjacent means sitting or means next to or right beside. And there are actually two sides that are adjacent. This one and this one to this angle are two sides that are right beside it. So how do we pick which one is adjacent? Well, the answer lies in looking at the third side, the hypotenuse. Now, only one of these could be the hypotenuse. Only one of these is the longest side of a triangle, of a right triangle, and that is this one right here. So the adjacent must be this one at 1.73, and the hypotenuse is this one here at 2 centimeters. Very similarly, if we go over to the next triangle, the opposite side to this angle is 2 centimeters long. The adjacent side is 3.46, and the hypotenuse is 4 centimeters. Now, what I'd like you to do is determine the ratios listed for each triangle. So take the opposite divided by the hypotenuse, take the adjacent divided by the hypotenuse, and list all of those answers right over here. Take maybe 2 minutes to do that, and then see what you notice. Okay, so hopefully you are able to take the opposite, which is 1, divided by the hypotenuse, which is 2, and 1 divided by 2 is 0.5. Okay. Adjacent divided by hypotenuse, 1.73 divided by 2 is about 0.865. And opposite over adjacent, 1 divided by 1.73 is about 0.578. Now, if we look at this triangle, which is a little bit larger, we can see that the opposite divided by the hypotenuse, this would be 2 divided by 4, and that gives us 0.5 as well. When I take the adjacent, 3.46, and divide that by the hypotenuse 4, I get 0.865. And when I take the opposite, which is 2 centimeters, and divide it by the adjacent 3.46, I get about 0.578. The last question I'm going to ask you is, what do you notice? Pause the video right here and see if you notice anything. Well, there's lots of things to notice in the situation. One thing to notice is that, hey, this triangle is just a very like a double this triangle that's double the size of this triangle. If you notice, all of the side lengths seem to have been multiplied by 2. Even this times 2 is 4, and 1.73 times 2 gets us 3.46. That's certainly one thing to notice, that these two triangles are similar and that this one is just a bigger version of this one. Another thing that you might have noticed is, hey, when I took the opposite side and I divided it by the hypotenuse, I got 0.5 in this triangle and in this triangle. Even though this one was bigger, even though all the sides were bigger, when I divided the two sides, I ended up getting the same number. And that happened for the adjacent over hypotenuse and the opposite over the adjacent. And so one thing to pull away from this investigation is that when you have right triangles, no matter how big the triangle is, if the angles are the same, then the ratios, which this is a ratio right here, all of these are ratios, the ratios of the corresponding side lengths are always the same as well. And by corresponding side lengths, I mean if you take this angle over here, the opposite side and the hypotenuse, if I divide the opposite by the hypotenuse, like we saw here, we got the same number. And these ratios actually have very special names. The opposite divided by the hypotenuse is called the sine ratio. Sine of an angle, and this is a Greek letter here. I know you saw it pop up over here in the triangle as well. This is a Greek letter. It's called theta. And the sine ratio of any angle is equal to the opposite side divided by the hypotenuse. And even if that triangle is a lot smaller, as long as that angle is the same, the ratio will always be the same. The next ratio that you have to know is called cosine, and we write it like this: cosine of theta, cosine of an angle. The cosine ratio of any angle is equal to the adjacent side divided by the hypotenuse. And the last one is called tan. The tan ratio of any angle is equal to the opposite side divided by the adjacent side. In any triangle, depending on which angle you choose, you can find out the value of any of these three primary trigonometric ratios. We call them the primary trig ratios for short. The first trig ratio is sine. That's the ratio of the opposite to the side that is opposite the angle to the hypotenuse. Cosine is the ratio of the side that is adjacent to the angle to the hypotenuse. And tangent is the ratio of the side opposite the angle to the side that is adjacent to it. In other words, sine of some angle is equal to opposite over hypotenuse, cosine is adjacent over hypotenuse, and tan is opposite over adjacent. And there's an easy way to remember these three ratios. Kind of sounds like a Polynesian name here. SOHCAHTOA. SOHCAHTOA. So SOH, that's S stands for sine, O and H stand for opposite over hypotenuse. Ka, cosine, AH, adjacent and hypotenuse, and TOA, T is tan, O is opposite, A is adjacent. And if you need to solve a right triangle, you have to use one of these three ratios. And the only thing you really have to do is find out which two side lengths am I comparing? Am I comparing the adjacent and the opposite? Oh, well, that would be this ratio. That would be the tan ratio. And I can use that to figure out exactly what that angle is. So if you actually know what the ratio is, there's a way for you to find out the angle. And if you look at your calculator right now, pause the video here if you'd like and take a look for these three buttons. And if you want to, if you have the ratio and you want to find out what the angle is, you can actually use the something called the inverse of the function, sine inverse of x, which should be on your calculator, those exact same buttons, but it is usually the second function, or you have to press shift before you press these buttons, and then it'll take the inverse. So one way to find out an angle is you could put in a ratio and then press the inverse button, and it'll tell you exactly what angle would create that ratio. In this example, we have triangle DEF. It's a right triangle clearly. And the length DF is 13.4 centimeters. And angle F is 33 degrees. What's the length of DE to the nearest tenth of a centimeter? So in this case, I'm trying to find out this side length here. This side length is opposite the angle that I know, right? So this problem involves an angle, the side that is opposite it, and the hypotenuse of the triangle. So if I have opposite and I have hypotenuse, which trig ratio involves those two? That's sine, right? SOH. SOHCAHTOA, SOH. So means sine is opposite over hypotenuse. And in this case, sine of the angle, 33 degrees, is equal to this unknown length, so I'm going to call that x, divided by the hypotenuse, which is 13.4 centimeters. Now, of course, if I want to isolate x, I just have to multiply both sides by 13.4. And when I multiply by 13.4, that will cancel it out on this side. And then I just have to do the same thing to the other side, just like that. And on my calculator, if you actually try to type sine 33, it'll give you a long string of digits. And the first four digits are 0.5446. So that's the approximate ratio of the opposite to the hypotenuse if the angle is 33 degrees. And so if I take that and multiply it by 13.4, I'll find out that the value of x is 7.2982 approximately, which I'm going to round to the nearest tenth, which is 7.3 centimeters. That's how you find the measure of an unknown side length if you have, and notice in this triangle, I have an angle, a side, and another angle. I have three pieces of information about this triangle. And because I had an angle and I knew it was a right triangle and I had one other side, I could find out the side that I didn't know. I could even find out this side if I wanted. In this example, we're going to find out the length of this side here. Now, in a triangle, whenever you see a triangle like this, ABC, and it says, hey, find side length B, for example, what that means is the side length that is opposite the same letter angle. So the same letter would be B. The angles are usually written in capital letters or uppercase, and the side lengths are written in lowercase, and they're written in a way that matches these right here. So in this case, this would be side B, this would be side A, and 16 would be the measure of side C because that's opposite angle C. Now in this case, I have an angle and I have the side length that is adjacent to the angle. I have 16 meters. I don't know what the hypotenuse is. I don't know what the opposite side is. I'm asked to find the measure of side B, and that is the hypotenuse. So because my problem involves the adjacent side and the hypotenuse, the sine ratio that uses adjacent and hypotenuse is, let's see, so TOA. That's my way to remember it. So pause the video here and see if you can figure out which ratio is the right one to use, and then see if you can use that ratio to find the measure of side length B. Well, let's see if you got it right. Since I'll be working with adjacent and hypotenuse, the right one to use, certainly adjacent and hypotenuse would be here. And the only ratio that where I highlighted both the sides is this one right here. And that tells me that I need to use the ratio cosine. So cosine of angle A is equal to the adjacent over the hypotenuse. And angle A is 28 degrees. So that's equal to adjacent, which is 16, divided by the hypotenuse, which is just B. I don't know what B is. So how do I find the value of B? Well, just like in all algebra, we just have to isolate it. Now the problem here happens because B is in the denominator. And the way to get rid of it in the denominator is to multiply both sides by B. That'll remove it from the denominator here. And when I multiply this side by B, I get B times cos 28. Now B is no longer in the denominator. It's still not isolated though. It's still being multiplied by cosine of 28. So I can do the opposite of multiplying. I can divide. Now cosine of 28 is a number. It's a very specific number. It's a ratio. I'm going to leave it written as cosine of 28 just for now. And it's going to cancel out. And then I have to do the same thing onto the other side. So what is 16 divided by cosine of 28? If you put that into your calculator all at once, it'll tell you that the length of B is about 18.12112, which I'm going to round to the nearest meter. That's going to be about 18 meters. In this next example, we're asked to find the measure of angle A to the nearest degree. Now here we're asked to find in an angle, not a side length. And I know two of these side lengths here. I can use, if I wanted, because this is a right triangle, I could use Pythagorean theorem to find the measure of this side, but that won't actually make my life any easier. In this case, if this is angle A, I know the opposite side length is 8 meters long, and I know the hypotenuse is 16. So pause the video here and see if you can figure out which is the right ratio to use, and then see if you can use that ratio to actually solve this problem. Well, if we go by SOHCAHTOA, because I have the opposite side, that's O, and because I have the hypotenuse, that's H, that tells me that SOH is the right call for me, and that tells me that I have to use the sine ratio. sine of angle A is equal to opposite over hypotenuse. And sine of angle A then is equal to the opposite, which is 8, divided by the hypotenuse, which is 16. How do I find out what angle A is? Well, just like we said on your calculator, every operation that you do has an inverse. So for example, the inverse of addition is subtraction. The inverse of multiplication is division. The inverse of taking something to the power of n is actually taking the nth root of that. The inverse of sine, cosine, and tan, these are all ratios. These are all operations that your calculator can do, and all of them have the exact same sort of inverse. They each have their own unique inverse. So the sine inverse, the cosine inverse, and the tan inverse. And the reason I bring these up is because if you were to say have an equation that looks like this, 5x plus 2 equals 12, you might say, okay, well, I'm going to isolate this by subtracting 2 from both sides. And the reason I'm going to subtract 2 is because the opposite of adding is subtracting, and I'm adding right over here. And then if I subtract 2 from the other side as well, because I have to do that to keep it equal, I get 5x equals 10. Now, how do I get rid of the 5? This is multiplication. The opposite of multiplication is division. So I might divide this side by 5. That'll cancel it out. And then I have to divide this side by 5 as well. And I find out that x is equal to 2. Big idea here is whenever there's an operation happening, if you want to undo it, you have to use its inverse. And over here, we have a very similar situation where we're taking an unknown value and we're doing an operation to it. That operation is sine. And if we want to undo sine, we have to do the sine inverse. And that will cancel it out, just like multiplication and division cancel each other out. And then we have to do the same thing to the other side, just like we did over here. So if I do the same thing to the other side, I find out that the angle A is equal to the sine inverse of 8 over 16. 8 over 16 is 0.5. And if you look on your calculator, you press that shift or second button, and then you press sine, you'll get the sine inverse. Do the sine inverse of 0.5, and you'll find out that this angle is exactly 30 degrees. If you like this video, please like, rate, subscribe, and join our mailing list. And you can find this lesson as well as practice questions, solutions, handouts, and more on our storefront. Thanks and have a great day.